Okay, we're looking at an example of a sampling distribution of sample percentages. The Grocery Manufacturers of America reported that 76% of consumers read the ingredients listed on a product's label. Assume the population proportion is P equal 0.76, and a simple random sample of 400 consumers is selected from the population. What is the probability that the sample proportion will be within 0.03 of the population proportion? In this case, we are given the population proportion, or percentage, as 0.76. The symbol we use for population percentage is P. The symbol we use for sample percentages taken from random samples is P with a caret on it, sometimes called P caret, P hat. It's the sample percentage, and in this case, we're taking samples of size 400. Now, we learned in this section that the distribution of these sample percentages is normally distributed around the population percentage and has a standard error or standard deviation given by this formula. It would be the square root of the population percentage times its complement divided by the sample size, 400. This calculation turns out to be 0.0214. Now the problem wants to know the probability that if we take a sample of size 400 and calculate the sample percentage on that sample, what's the probability that that sample percentage will fall within 0.03 of our population percentage, 0.76. Now, the standard deviation of this is only 0.02, so the 0.03, if we go out 0.03, we're probably going out around 1.5, somewhere around there, standard deviations. So that would be equivalent to going down to 0.73 and up to 0.79. Problem is asking us to do is to find the probability that the sample percentage is somewhere between 0.73 and 0.79. I also want to make a quick note that I do have symmetry here. I've gone the same distance from the center. To answer this question about the probability, I know that that's going to be the area under the density function above the interval. And I know that that density function is normal. Now, I want to translate this to z-score. And because of symmetry, I only need the z-value for the 0.79. So 0.79 subtract 0.76, or 0.03, divided by 0.0214 equals 1.40. So the 0.73 has a negative 1.40, and the 0.79 has a positive 1.40. But working with our standard normal table, and since I'm going to be right here symmetric around the center, I'm going to look up the 1.40 and find this area to the right of the center out to the 0.79. So going to the table and looking up 1.40 would put me here. 0.4192. 0.4192. So 0.4192. Well, that would be also this side. And then my probability statement to finish that out. Probability that the sample percentage is between 0.73 and 0.79 is the probability that the z-value is between a negative 1.4 and 1.4, and that is 2 times 0.4192, which equals 0.8384, or approximately 83.8% probability. If I take a sample of size 400 from this population, and I calculate a sample percentage on that sample percentage will be within 0.03 of the population 0.76.